Okay, so here are another couple of equations, quadratic equations, that we're going to solve using the factor method. And remember, the first thing you do is get everything on one side of the equation. So for this first one right here, I am going to add 4x squared to both sides. Alright, so on this side, I'm going to have 0. There's nothing left. I subtracted negative 4x squared, well, I added negative 4x squared plus 4x squared, so that's 0. So there's nothing left over there. And then on the left side, I've got 4x squared minus 25. All right, and you can see that this is a difference of squares. It's a difference because it has a subtraction sign. And there are two perfect squares here. You've got 4x squared, which I could write as 2x, the whole thing squared, because 2x times 2x is 4x squared. And then 25 is 5 squared. So when you have something squared minus something squared, it equals the product of the conjugates, which means first thing plus second thing times first thing minus second thing. All right? And that's supposed to equal 0. And by the zero factor theorem, if you have the product of some things and it is 0, one of those things has to be 0. So here are the two factors. 2x plus 5 is a factor, and 2x minus 5 is a factor. They are multiplied together, so they are factors. So either 2x plus 5 is 0 or 2x minus 5 is 0. Solve for x in the first equation here. Subtract 5 on both sides. So 5 minus 5 is 0, so 2x plus 0 is just 2x, and that equals negative 5. And so divide by 2 on both sides. That gives you x equals negative 5 halves. All right, on the other equation over here, you've got 2x minus 5 is equal to 0. Add 5 on both sides. So 2x equals 5. Divide by 2. Sorry, we've got a birthday party going on here, so it's pretty loud. X equals 5 halves. So these are the two solutions to this equation. These are the two roots to this equation. X equals 5 halves or negative 5 halves. All right, so next one, we're going to do the same thing. 3x squared minus 6x equals 9. We're trying to find the roots or the solutions of that equation. I'm going to go ahead and erase this so it's not in the way. All right, so first thing we do is get everything on one side. Get 0 on one side and everything else on the other side. So I'm going to subtract 9 on both sides of this equation, and I'll be left with 3x squared minus 6x minus 9 equals 0. All right, next step is to factor out any common factors, and you can see that these three terms all have a factor of 3. So if I factor that out, what am I left with? For the first term, I'm left with x squared. Second term, I'm left with minus 2x. And for the last term, I'm left with minus 3, right? Because if I divide out a 3 from 3x squared, I have x squared left. Divide 3 out of 6x, and I have 2x left. Divide 3 out of 9, and I have 3 left. So just make sure that when you multiply this out, it equals the thing you started with, 3x squared minus 6x minus 9. All right, now I'm going to factor the quadratic. Remember, when you factor a quadratic trinomial, the first two numbers should multiply together to give you x squared. So x times x is x squared. Then the last two numbers, their product should be negative 3, and their sum should be negative 2. So the product should be negative 3, the sum should be negative 2. All right, negative 3 is prime. 3 is prime, so you know it's got to be 3 and 1. But one of them has to be negative, so it'll be negative 3, because you need negative 3 times positive 1, or positive 3 times negative 1 to get a negative 3. But the 3 needs to be negative, because negative 3 plus positive 1 is negative 2, and that's what you need for that middle term, that x term. It needs to be negative 2. All right, so now you've got three factors multiplied together to give you 0, so one of them has to be 0. Here are your three factors: 3, x minus 3, and x plus 1. 3 can't be 0, so we don't need to worry about that. X minus 3 could be 0, and x plus 1 could be 0. If you add 3 on both sides of this equation, you get x equals 3. If you subtract 1 on both sides of this equation, you get x equals -1. So these are the two solutions to this quadratic, and if you plug them in, you'll find out that they actually do work. If you put 3 into that equation, you would have 3 times 3 squared minus 6 times 3 equals 9. And that is 3 times 9, which is 27. I ran out of room here. Let me just use this eraser. So 3 times 9 is 27, minus 18 equals 9, and that's true. So 3 works. And then if you put in -1 into that equation, you would have 3 times -1 squared minus 6 times -1 equals 9. So that's going to be 3 times 1 is 3, minus 6 times -1 is -6, so plus 6. And that does equal 9. So these two are the solutions of this quadratic.